Hi everyone, welcome back to Math 18A College Algebra. It's a very nice day outside today. It's a shame that I have to be inside. Well, anyway, another day, another section of our college algebra textbook. So today we're going to be doing section 4.4, properties of logarithms. So we're just going to be building on our knowledge of logarithmic functions, which we studied in the last section. And today's a pretty short section, so it shouldn't be a very long lecture. Yeah, I'll just be giving you some properties. So let's get right into it. Okay, we'll start with the change of base formula. You use this when you want to change the base of your logarithm, obviously, to something easier to work with, maybe. So let a, b, and x be positive real numbers such that a is not equal to 1 and b is also not equal to 1. Then log base a of x equals log base b of x divided by log base b of a. So this is just a way of taking our log base a of x and making it into a log base b function. Maybe you want to convert it into base 10, because base 10 is easier to work with as the log button on our calculator is base 10. So then you could just plug this into your calculator and figure out the answer. So you could change it to base 10. This one is base b, more general. You can also do base e, remember our natural log. So you could say log base a of x equals natural log of x over natural log of a. So let's go ahead and apply our change of base formula to an example. So evaluate log base 8 of 56 using common logarithms base 10 and natural logarithms base e. So we'll do both of these and we should get the same answer. And so notice that log base 8 of 56 is asking 8 to what power gives me 56? And so that's not something simple that we'll be able to solve just like thinking about it in our heads. So we'll want to use a calculator for this. So let's convert to base 10 first. Log base 8 of 56 equals what in base 10? And let's go back to our change of base formula for a second here. If I want to go to base 10, log base a of x equals log base 10 of x over log base 10 of a. So this is going to equal log base 10 of x, which is this 56 here, over log base 10 of a, which is 8 here. So now we can plug this into our calculator now using just the log button, because that's log base 10. So we'll do log of 56 divided by log of 8. And that's going to give me 1.936 if I round it. It asks us to round to 3 decimals. I didn't write that down, but take 3 decimals, I guess. Okay, so that is our log base 10. Let's now try it with the natural logarithms, which should work the same way. Log base 8 of 56 equals natural log of 56 divided by natural log of 8. So we'll go ahead and plug that into our calculators again. Natural log of 56, ln, divided by natural log of 8 gives me the same thing, 1.936 if I round it to the 3rd decimal there. There are a few more properties of logarithms that are pretty interesting and useful, and they allow us to expand and condense logarithmic expressions. So let's let a be a positive real number such that a is not equal to 1. let n be a real number, and let u and v be positive real numbers. Then we have the following properties. Using base a, a general base, log base a of u times v equals log base a of u plus log base a of v. So we can separate this product into a sum of two different logarithms here. And we can actually do the same thing for base e. Let me just write it out. It works exactly the same way. So if I have natural log of u times v, then that equals natural log of u plus natural log of v. Alright, going back over to our base a, if we have a quotient, log base a of u over v equals log base a of u minus log base a of v. So if we have a quotient, we can separate it into a difference of the top minus the bottom. And I'll write the same one for natural logs over here. Natural log of u over v equals natural log of u minus natural log of v. And finally, this last property here, log base a of u to the n, so a power, u to the n, right, equals n log base a of u. So that's saying that if you have a power like this, you can bring it out to the front of this log, which kind of makes sense because we use logs to like get the power down from where it was, right? So yeah, u to the n becomes n log base a of u. And the same thing for natural log. If I have natural log of u to the n, then that equals n natural log of u. And if you are going on to business calculus, these properties definitely show up. When I worked as a tutor, I had a business calc student come in and ask for help, and yeah, he had to do this quite often, expanding expressions, condensing expressions using these properties. So we'll go ahead and do some examples so you guys know how to do it. So first example, we want to write log base 10 of 25 over 3 in terms of log base 10 of 3 and log base 10 of 5. So probably the first thing that stands out is this is a quotient. So that means we can split this up into a subtraction expression. So first, notice, or we already sort of noticed, so split it into a difference. So log base 10 of 25 over 3 using our quotient property is log base 10 of 25 minus log base 10 of 3. So that's the first thing. We're not quite done yet because we want to write this in terms of log base 10 of 3 and log base 10 of 5, not 25. So the next thing to notice is, well, I can write 25 as 5 to the second power. So 25 equals 5 squared, right? So I'm going to rewrite this now. Log base 10 of 5 squared minus log base 10 of 3. And so now I have this power that I can bring to the front using that power property. So apply like power property. And so that works by bringing this 2 out in front. So it'll just end up being 2 log base 10 of 5 minus log base 10 of 3. And so now we have it in terms of our log base 10 3 and log base 10 5. So if it doesn't ask you to evaluate, then we're done here. All right, another quick example. We're asked to expand natural log of 2mn squared And so expand means we want to write it, well, kind of exactly what it sounds like. Like, write this as more terms, not just one, right? So let's write it in as many terms as we can. So we have natural log of 2mn squared. The first thing to notice probably would be we have a product. And so we can use our product property where we can write our product as a sum of natural logarithms. So write as a sum. Okay, we can do that. So let's look at all of the different terms that we have here. We have this 2, we have m, and we have n squared. So we'll split all of those up actually. So we actually have natural log of 2 plus natural log of m plus natural log of n squared. That ln got a little bit funky, sorry. So we've written this as a sum now, and that's the farthest that we can split it in terms of products. Then the next thing to notice is, again, that power. So note the power. And so we'll just want to apply the product power, or the product property, or no, not the product, the power property. Apply the power property. Alright, so then we can just rewrite that as ln of 2 plus ln of m plus, remember the power brings it to the front, so 2 ln n. And that is the farthest that we can expand this. So that would be your answer for expanding the expression. So now let's do an example that does the reverse. We want to condense a logarithmic expression to log 10 of x plus 1 minus 3 log 10 of x minus 1. So first, we want to notice these coefficients here. So note the coefficients. And remember that those are actually powers. So, like, apply the, power property. So we're kind of going in the reverse order of expanding. We want to first do the powers. So let's put those back up where they came from. Log base 10 of x plus 1, taking this 2 as the power, that's going to be squared. And then minus log base 10 of x minus 1, taking that 3, putting it back, cubed to the third power there. Alright, so we've got those back. Let's now notice that we have a difference. So if we have a difference, that means that it came from a quotient. Difference. So apply the quotient property. So if we had a difference, or if we have a difference, that means that we have log base 10 of this argument over this argument, because it's u minus v, so it was therefore u over v. So let's go ahead and just apply that. Log base 10 of x plus 1 squared over x minus 1 cubed. And so that's actually condensed as far as we can take it. We can't be careful with these arguments, this x plus 1. Like, you can't split those up in any way. We can't condense that any further. So, yeah, this is going to be the final answer. Alright, and of course, one of these almost always shows up on the final. So let's go ahead and do a past final example. Expand the expression natural log of this whole thing, x minus 11 to the 5th, square root of x squared plus 7 over x minus 3 to the 4th, as a sum, difference, and or multiple of logarithms. So just using the properties that we know how to use now. We want to expand this. So it looks very intimidating, but we just need to take it one step at a time, break it down, and it shouldn't be too bad. So probably the first thing that I would like to deal with is if you have a square root, we kind of don't know how to deal with that yet using any of the properties, but remember that you can change a square root to the power 1/2. Right, so remember that the square root of x is the same as x to the 1/2 power. So we'll go ahead and rewrite that whole thing. Natural log of x minus 11 to the 5th, and then this thing becomes x squared plus 7 to the 1/2. The whole thing goes to the 1/2, right? Don't split it up or anything. And then over x minus 3 to the 4th. Alright, so now we have it in things that we can work with. So we can sort of tackle the sum and difference parts, the quotient and product, all at the same time. So now, like, apply product and quotient properties. So we need to be able to identify what we're multiplying, what we're dividing by, like sort of separating our terms. So this x minus 11 to the 5th will be one term, this x squared plus 7 to the 1/2 will be a different term, and this denominator here, x minus 3 to the 4th, will be our last term. So we can go ahead and do that. Natural log of, let's just take the first one there, x minus 11 to the 5th. That gets multiplied with this second term here, so it's a plus natural log of x squared plus 7 to the 1/2. And then this one in the denominator gets subtracted because that is a quotient. So natural log of x minus 3 to the 4th. Alright, so I did a couple steps in one, but in my head, that's kind of the easiest way to do it. You can just recognize your different terms here and either add or subtract them depending on if they're in the numerator or the denominator. So we've expanded it now, and then the last thing to do would be to apply our power rule, right? Our power property. So let's go ahead and do that on the next page. 3. Apply power property. So taking this first term here, we have the 5 as a power, so we know that that one has to come out to the front. So 5 natural log x minus 11 is what we'll have there. 5 natural log of x minus 11. Next we have this 1/2, so that's going to come out to the front of our second term there. 1/2 natural log x squared plus 7. So plus 1/2 natural log of x squared plus 7. Make sure I copied that correctly. Yes. Okay, so we have our two terms now. Let's look at the last one. we're going to be bringing that 4 out to the front as well, and make sure we still subtract that last term there. So minus 4 natural log of, I forgot what it was, x minus 3. Okay? And, like, these arguments in here, remember we can only expand it if it's a product or quotient, so we can't expand these any further, and we can't bring this power on the x squared out, so, like, can't expand these. Or bring the powers out. It's only when you have a like a single term to a power or a product or a quotient. So this will be our final answer for this problem. And one more thing to notice is it asks us to write it as a sum, difference, or multiple of logarithms. So we have these coefficients make it multiples, and then we can see that we have the sum and the difference here. So that'll be the answer. And remember, these properties hold for any logarithm, so you can do log base 10, log base a, whatever. You could still separate them like this, expand your expression. Okay, so that was all that I needed to cover today. Thanks for watching, guys. As always, if you have any questions, feel free to stop by our Zoom meeting during the class time, but otherwise, see you next time.